Speaker Freak, what's up, buddy? What's up, yo? Again, good evening. Good evening to y'all. Chris, what's up? Evo, what's up? Friday night, y'all. Friday night in the workshop. That's my life. Lots of people are waiting for this. Hi from Finland! Ah, what's going on? I love Finland. And mostly, as well, I really love the Finnish accent. You know, when spoken in English, the Finnish accent is wonderful. From Norway, also really like Norway. Awesome. Lots of people around here. Pennsylvania. I've never been there, but welcome. Thank you for joining in the stream. That's the thing in Finland. When it gets cold, it gets fucking cold. I think in Finland, what temperature does like a good normal summer generally reach? Is like 20 degrees or like 30 degrees or something? Is it, or like, yeah? What's the summertime in Finland like? My microphone keeps moving itself. I keep knocking it by mistake. So let me move my microphone a little bit closer, because, okay, there we go. That's now a good distance from my face, so you should be able to hear me quite nicely. There we go. There it is. Up a little bit. Thank you very much, Jesse. Yeah, not too bad. How are you guys all spending your Friday evenings? Trinidad and Germany and what else we got? No, Russia. From Poland. Hi, awesome. Poland's pretty cool. Russia? Summer gets like 20 degrees. It's okay. We've seen 30-degree summers also, and same the wind. Yeah, that's the thing. See, Finland, yeah. Finland seems to get a similar, possibly a similar summer to here in the UK. So summer here in the UK, like, when it's properly summer, we get like 25 to 32, but we generally only get that for a couple of weeks, and then it's just raining and shit. But when it is proper summer, it's like 25 to 32, but in the winter, it's like, the lowest you get is like -2 sometimes. But in Finland, it's -20 to +25. It's like a much bigger range, and you get the best of both worlds. Like I've seen some scenery in Finland in the winter time, and all the frozen lakes and everything is covered in snow, and it looks beautiful. And because the winters generally are like that for a long period of time, the way of life appears to be quite relaxed and everything's quite cool and chill, and they have saunas in the houses and things. It looks really nice. I must visit Finland sometime. I visited Sweden, and I visited bollocks, where did I visit? Somewhere near Sweden. Where was it? I went for New Year's. I can't remember where it was. Czech Republic, California. Okay. CC1 a few weeks ago. Yeah, the CC1, yeah. See, that's a bit different. I don't know if there's a cheat way around the CC1, but there's a cheat way around the DD-1. It's hard to subwoofers in winter. It's cold as fuck. In summer, it's hot. So cheap Chinese glues get loose, and yeah, that's the problem. Massive differences in temperature cause problems for glues and moving parts and material like foam and things like that. So yeah, it's very hard if it's -20 outside and your car is -20 because it's been out in the night time, and you come to the morning and you want to turn your subwoofer system on. Your subwoofer is -20 degrees. and that will change the TS parameters, that will lower the resistance, and and also when your car warms up inside, then you get condensation on the amplifier, because the amplifier case is still cold because it has a high thermal mass, and so then the parts inside cause condensation, and then the amplifiers can blow. Greetings from Argentina. Awesome. So we've got our range of people going on here. So this video is something that I've wanted to do for a little while now. Got a few people watching. See this stream, right? This stream has picked up nicely. We're already at 55 viewers. The last night I did this last night. And it was at like 2 in the morning here, which I assume was like, I don't know, 11, 10, like maybe 9, 10, 11 o'clock in the States. But not a lot of people could tune in, and so I think I had like 20 viewers. But I did this last night already, but I said, we've only got fuck all viewers, so let's do this again tomorrow. So for any of you who were here last night, apologies you're seeing this twice, but I wanted to do this again for anyone that missed it, because well, I didn't have any viewers at all. Amps sweat in the winter going to protect. Yeah, that's very true. I would not like that. I guess in the UK it's not so bad because the range is much shorter, so therefore the temperature differences don't affect the equipment quite as much as it would do in those countries. But still, Finland's beautiful. I wanted to do a video actually, which was going to be pretty funny. I was going to take a relatively like low cost speaker, like just some subwoofer, maybe an 8-inch because it needs to be small for this video, and what I was going to do is I was going to buy it new. I was going to break it in so you could see how the TS parameters change on break-in. Then I was going to put it in the freezer, so I was going to freeze the subwoofer in the freezer, take it out and measure the TS parameters again whilst it's freezing cold, so you can see the difference between the TS parameters of how the subwoofer will sound compared to room temperature, then frozen, and then I was going to put it like in the oven but on a really low temperature, just to like maybe get it up to like, I don't know, say sort of like 60-70 degrees on the parts, and see again how that affects the TS parameters. And what we'll notice, I imagine, is that when the woofer is cold, the mechanical compliance will go. Wait, I've had a few drinks, so I can't. So it'll be a lot stiffer. So the FS will rise, and also because the lower temperature, the resistance will be lower. So the DC resistance of the coil will be lower. So therefore, it will draw more current from the amplifier whilst the coil is cold. And that's why it's a good idea if you're ever going through the lanes, if you're ever going to a car audio competition and you're going to be burping some tones, a lot of people get the urge to bass their car while they're in the queue for the lanes or whilst they're at the show before they go and test. And this is bad for a number of reasons, because firstly, you drain your batteries, and secondly, you are heating your voice coils up and you're heating the components inside your amplifier up, and so when it then comes to your turn to drop the tones in the lanes, your resistance of your voice coils and your amplifier traces are higher and your batteries are more depleted. So not only do you have less power due to your higher resistance in the voice coils, but you also have less cold cranking amps from your batteries to start with in the first place anyway. So yeah, if you're going to go to a show and you're going to compete, don't play until you competed. Once you've gone through them lanes and you've got them scores, then sit there and crank it up and have some fun, for sure. The Real Ray's Fury, how's it going, buddy? How's it going? Okay, cool. We're 64 viewers now, so I'm going to start this video in a moment. This is ye old clipping detector. Ye old clipping detector. This has been a much waited for video, but from many people. These lights are hella bright. Let me see if I can just twist these to the side a little bit. Get these out of the camera a little bit. There we go. I risk knocking my head on that though. That's a bit better. That's a bit better. You can kind of see my head now. I've not got this kind of halo glow around my head, around my face. What's up, yo? In the winter, it's 1 foot of snow deep. Fuck that. John Mix. Hey, John Mix is on the stream. What's going on? Friday night. What's everyone up to on their Friday night? A couple of people in the workshop and that already. I'm not doing any work this evening. I've done some work this evening already. I'm finished work now, but I wanted to show this demonstration to you. So I'm in the workshop at the moment. Okay, right. Let's get this video started. So, to detect clipping, there is not a lot of options for some piece of equipment. Generally, people just go for the SMD DD-1, and I think this is quite an expensive piece of equipment just to tell you what point on your dial the thing is going into a square wave. Now, the method that I'm going to show you is quite a well-known method among people that are electrically knowledgeable, or electricians, or like technicians, and things like that. This is a really stupidly simple thing that you can do, that some of you will probably know already anyway, but there are a lot of people who maybe it hadn't crossed their mind that you could do this, so I wanted to show it to you. Still waiting to be picked up from work, so I chill at home, says Jesse. Yeah, no worries, no worries. I think he's on his way just now. So anyway, now if you think about, so when your amplifier clips, it creates a square. It starts to square off the top and bottom of the wave. So before clipping, the sine wave is beautifully smooth, and the only frequency that's emitted from the amplifier, whilst the amplifier is playing clean and not clipping, is the low frequency which you're playing. No other frequencies are emitted from the amplifier, okay? However, when you go into clip, when the wave starts getting squared off at the top and the bottom, due to the sharp edges of the square wave, of the squaring off of the sine wave, you actually end up with a kind of high frequency buzz that rides along the sine wave, which is what sounds like distortion. That's what you can hear when you hear a square wave. The kind of sharp buzziness that you get with a square wave is the fact that there is another frequency which is riding along the sine wave to cause that kind of buzz. And that frequency that you hear, the buzzy kind of sound, is actually quite a high frequency. So, let's now think about how a tweeter works. You have a tweeter with a crossover, a capacitor in series with a tweeter, and what that does is it filters out all the low frequency to just allow you to hear the high frequency. So think about it this way: if your subwoofer amplifier is designed to only emit low frequencies, but when it clips it emits high frequencies, then the simple answer is to hook up a small speaker with a tweeter capacitor in series with your bass amp, and then you will hear the distortion sound quite loudly from your tweeter or your small speaker when the amplifier clips, but you won't get any of the bass. So your subwoofers will still be doing 150 flipping dBs at 30 Hertz, and your small speaker in your hand that has the capacitor in series won't move an inch, and then when the amplifier clips, it'll buzz. Let me show you a demonstration of that happening. So here we have on the bench an SPL Dynamics ICE 1500D. This is a really flipping common amplifier. This is your real basic sort of 1500 watt cheap. I think it's a Chinese build amplifier. These boards are very common and they're in many brands. I don't know all your American brands, but there's fucking loads of brands that use this board in the UK. So 1500 watts. That's a fair amount of power for a daily system. You know, your daily system, maybe you're keeping on stock electrical, or you got one extra battery, or you've done a little bit of extra cabling. It's not going to demand a huge amount in your system. So this is a good amount of power for the general everybody. You know, there's quite a lot. You know, out of everyone, the average power is probably going to be somewhere around 1,000, 1,500, 2,000 watts RMS. So we take our standard amplifier and we play. I'm going to play a 33. Roughly 33.6, but I'm going to play 33 Hertz tone through this, okay, and we'll see the tone on the oscilloscope, so you can see that the amplifier is playing clean. And when it starts to clip, I have this really small speaker. Everybody has spare speakers laying around. Everyone has spare shit laying around like this. Fucking little tweeter, little spare old speaker, component speaker, 6-inch thing, anything. And then all that I've done is I've put a capacitor in series with the tweeter, the speaker, sorry, to filter out the low frequencies, so that only the high frequencies are passed to this speaker. So when the amplifier clips, we will hear distortion through this speaker, but nothing else. Now, the capacitor that you need is very specific, and I'll go over that in a moment. But let me just show you the demonstration. So let me turn the amplifier on. Amplifier comes on with a blue light, we can see here on my hand. Okay, a little bit of high frequency from the coil switching. So as we can see on the scope here, we have a sine wave there. And now, if I turn this up, we can see the sine wave bigger. So this is the amplifier playing beautifully clean. And there is absolutely nothing coming out of this speaker. This speaker is doing absolutely nothing at all. It's just sitting there like la la la, not doing anything. But I actually have a load connected to this amplifier, and this is giving 17 volts. So 17 volts AC is currently going to the load. You see? So there's no sound coming through the speaker while the amplifier is playing clean. But as soon as we hit clip point, suddenly the tweeter starts making a noise. So this is your clip point. So you can hook this up to your amplifier and you can listen to this small speaker. You can have it on a really long wire from the back, or you can hook it up just, you know, to your sub amps. And when the speaker starts making a noise, you start hearing like from the speaker. That is when your amplifier is reaching the rail voltages in the amplifier and is starting to square off. So then you need to back off the gains just a touch, and then you'll be playing clean. So let's show you that on the big screen. So this is perfectly clean. Again, nothing coming through the speaker. As soon as we reach that clip point, you can see it here, bigger on the bigger screen. As soon as we reach that clip point, we start getting the distortion coming through. Now, this is just a very, very basic demonstration. There are, you know, much better upgrades you could make for this. You could even connect headphones to the amplifier through a resistor network and capacitor network, so that you can have some small headphones that you just plug into your amplifier that you can hear the distortion through. Now, this works perfectly fine, regardless of whether you're running a 500 watt amplifier or a 10,000 watt amplifier. The only thing that you need to make sure is that your capacitor is a high enough voltage rating. So for a capacitor, obviously, the capacitor I'm using here just for this small test, because it's the one that I had laying around, is a 100 volt 3.3 microfarad. So obviously, if you have a much more powerful amplifier, let's say you have a 10,000 watt amplifier, that thing can output, the sine wave will swing between like pretty much almost 200 volts. So you want to try and find a capacitor that is maybe a 400 volt non-polarized capacitor and around about 2.2 or 3.3 microfarads. And then you can hook it up to your small speaker. The small speaker won't do it. Let's have a quick look at what's going on the live chat. What's going on the live chat? I'm going to explain this in a minute as well, because people are just are pretty much just joining. So let's have a look. Is that for Class D only? No, this works for Class AB, Class D, Class T for tripath, Class GH. This works for any class of amplifier. You can use resistors also. Yeah, you can use resistors also. The only problem with using resistors is you are still going to get the low frequency come through whatever speaker you attach, and then therefore, because you're using resistors, the distortion sound is much quieter. Whereas using a capacitor, the distortion sound stays at the same volume as it would be without being lowered in volume like a resistor would do, but because it lets through the high frequencies, but it just filters all the low frequencies. I'm sorry if the stream keeps buffering my OBS software. Why? Okay, what else we got going on in the live chat? This is extremely simple and very effective. This only works for Class D and 33 Hz. No, this works for any class of amplifier and any frequency. So you can use any frequency you like, and the capacitor, as long as the capacitor is of a low enough farad rating that will filter out the frequency which you want to test for distortion. You can use any frequency. You can even play music. So you can play music through this and listen to the speaker for the distortion sound. I might do that actually. I might play some music through it if I can. I'll work out how to do that. So, for anyone that didn't see that, if anyone that's recently joined and didn't... 77%. No. Why that keeps dropping out. Very annoying. Anyway, for anyone that missed that, very simple clipping detector, amplifier, small speaker, capacitor in series, non-polarized, high enough voltage to support your amplifier's power. So you need to work that out. Very, very small farad rating, 3.3 microfarads or 2.2 microfarads in series with your speaker. Turn the amplifier on. You can. This time I'm gonna apply a load to the amplifier. So obviously you would do this with your speakers hooked up. So it doesn't make a difference whether you do this. How we do this. So let's just add a load to the amplifier just now. I'm gonna plug my dummy loads in. I'm just gonna plug a dummy load in here so we can see the same thing happens when the amplifier is loaded. So I'm just going to plug a dummy load in here like so. So that this is simulating a speaker load now. It goes in there like that. Okay, so we turn the amplifier on and we have a blue light like so. Okay, so clean audio signal on the oscilloscope. It's driving now a load, so we have our dummy loads plugged in, so it's driving a speaker. We're playing 33 Hz through the amplifier. I'm actually going to change the frequency so we can see that it works at different frequencies. Let's change it to a higher frequency. Let's go up to, I don't know, 45 point something, 45 Hz. So let's have a look at 45 Hz. Okay. So 45 Hz, let's turn the volume up until we hit clip point. So again, the amplifier is driving a load through our dummy loads. We have this small speaker hooked up as well to the amplifier speaker outputs with a small capacitor in series to filter out the low frequencies, because clipping emits high frequencies. So to detect clipping, we turn the amplifier up to clip point, and you can hear that the clipping distortion sound comes through the small speaker. So rather than looking at an LED on an SMD distortion detector DD-1, you can just take your small spare speaker. Everyone has small spare speakers laying around, and you can hook it up with a capacitor in series, and you can hear the distortion. Really simple, doesn't cost you anything. So yeah, there we go. There it is. Really fucking easy. Motion detector out of a pair of headphones as well. Yes, you can use headphones instead, and you can hook up a capacitor, and you will probably maybe need some resistors as well, because headphones are very, very sensitive, and they're also higher resistance. Which means that the capacitor won't filter the low frequencies quite as well. Capacitors filter low frequencies better when you have a lower resistance load connected to them. Bevis, how did you know about this method? I just thought about it. I thought it up. I just thought that this should work, and it worked, and so I decided to do a video. So the only cap I can find is a 1UF 450 volt. As long as, so A's Wizard, as long as the capacitor is non-polarized. So it should not have a positive and negative, it should be non-polarized. If you use a polarized capacitor that has a negative and a positive, it's going to explode. So don't use that. You need to use a non-polarized capacitor that doesn't have a positive or negative sign on it. And yes, 450 volts, 1UF will work perfectly fine. So with a rectifier, after the cap, you could... So someone says if you fit a... you wouldn't even need to fit a rectifier. You would not even need... after... So you could swap out. You could swap this speaker for an LED, and it would give you a flashing light when the amplifier was clipping. The same as the DD-1. Should we try that? I wonder what the voltage is across the speaker when it clips like that. Should we see what the voltage across the speaker is when it clips? Because I wonder if it's enough to drive an LED. So if I measure the voltage on this on the speaker positive here, okay. I wonder if it's enough to drive an LED. Nah, it doesn't. It's not enough to drive an LED. No. So you could design a circuit so that it was enough to drive an LED. That would be fine. That would be easy. But on its own, it's not enough to drive an LED. Yeah, I'm very sorry, guys. The stream seems to be lagging a little bit. I'm not too sure why. I've closed my browser and other things to try and fix that issue.